My name's Greg Burnet. I'm a remodeling contractor from the Chicago area. What I want to talk about today are some of the details from the JLC field guide. I have done a couple of sessions, or a couple sections out of the field guide from the exterior field guide, exterior details, and today I want to look at some interior details. Now, what we'll be looking at are common areas that we see problems with, particularly in older houses, though not exclusively to older houses. I want to start by talking about thermal bridging. Everybody know what thermal bridging is? Each one of these little lines where there's minimal amount of snow, where you can see the asphalt shingles, the roofing material, is a rafter. This actually indicates that the roof is fairly well insulated. It appears to have a decent ridge vent, and I'm assuming it's got soffit vents, because there appears to be maybe some convective currents at work and the ridge vent appears to be doing its job. But what's really at issue here is the amount of energy that's being lost through these bridges. Essentially what's going on is, my guess, not seeing the inside of the house, my guess is that there's finished material on the inside, drywall or whatever it may be, that is butted up tight to the underside of the rafters. The roof sheathing is obviously laid on top of the rafters, and that whole mass is conducting energy through its own form, through the wood. The insulation between the rafters is doing a fairly decent job, but because they haven't addressed the thermal bridging issue, there's a lot of heat loss here, and consequently there's likely a lot of ice damming on these types of roofs in the winters. Thermal bridging is not unique to roofs. It's present in every location where there's framing material. This detail, these illustrations here, are taken right out of the field guide. This detail down on the bottom is what we often encounter. This is what we typically see when we enter a remodeling situation. We see insulation, if there is any, between the floor levels that's wrapped around. The insulators got lazy and they wrapped it around, and they didn't actually cover the rim or the band joist. When we build new, typically remodeling, an addition or something like that, we use this detail at the top, A. We inset the rim joist, typically an inch, actually an inch or an inch and a half. If it's a 2x6 wall, we'll even go an inch and a half. And we'll put an inch and a half of rigid insulation on the outside. We'll cover that with a sheathing. And we'll tie everything together with the actual plywood sheathing on the outside. But that rigid insulation, and it can be as little as a half inch or 3/4 of an inch, acts as a thermal break. It stops the heat or the cold transfer through those wood framing members. That's its sole purpose. In addition to that, we'll insulate this cavity in here typically with either spray foam, rigid foam, or blown cellulose, wet spray cellulose in these applications. This is another area, headers. Headers and wall framing are another huge source of heat loss. I've got a couple mock-ups up here. I didn't bother to make a conventional header because we've all seen them. But in a typical application, whether it's a 2x4, 2x6 wall, what do? We take multiple layers of 2x material, we sandwich plywood in between them to get them to the correct thickness, and we install that. That is just a huge chunk of wood that's going to work as a thermal heat sink, and it'll release energy to the inside or the outside depending on the season, and conditioned energy that you don't want necessarily. So, alternates. This is one alternate. If you've got a 2x4 wall, substitute rigid foam instead of the plywood for your headers. You've created a thermal break. That heat mass cannot transfer through the rigid foam very effectively. It's a really easy substitute. If you've got a 2x6 wall, you can do the same thing. You can have 3 2x plus 2 layers of half-inch foam in there, or you can simply build this. This would be a 2x6 wall. This is a cross-section of the header, and the only thermal bridging that you'd have would be on the 2x6 bottom piece, and on the top plate, of course. You're gonna have that no matter what, unless, well, I'll get to that in a minute. There are other options. Point being that you've got an airspace in it. An airspace is more desirable than wood in this situation. It's not insulated, so you're not going to get insulation properties or insulation values, but it will be enough to stop that thermal bridging. We don't build it this way. We build it this way, with rigid foam laminations. My only caution is make sure that this is engineered. because in some cases an engineer will spec out a detail for a header that requires the use of plywood for strengthening purposes. By and large, it's overkill, but confirm it with your engineer before you automatically make the switch to foam and start substituting foam for the plywood. Another source of thermal bridging are on corners. When I started framing, when I started in the business 30 plus years ago, I framed for a contractor for a while as well. This is how we framed our outside corners. We took 2 studs and a bunch of drops and spaced them together so that we had a nailer on the inside for the drywall. Everyone's built that way, right? This is terrible. This is one of the worst ways you can build an outside corner. First of all, it's a complete waste of material. Second of all, how do you insulate these little pockets? I'll be honest, in the early 80s, we didn't insulate them. By the time I was working for another contractor, he was adamant about insulating them. Oh, we got to insulate those. So what did we do? We stuffed fiberglass in there. What does that do? We compressed it, we jammed it in there, push it in there tight, boys. There's no R value to that. It may stop a little bit of thermal bridging, but only right in here. It may give you a minimal insulation value. It's not going to give you any real value. The other issue is the fact that when it got wet, it was useless. And when we were framing, those frames got wet routinely. You can't protect that insulation. This is a bad detail. Literally, throw it away. And instead, build your corners like this. It's simpler, it consumes less lumber. More importantly, it allows the insulators to get in back of this corner stud. We frame all our projects this way. Any retrofits, wherever we can get in there, and we will make our best effort to get in here and insulate the heck out of that. As I said, we typically use blown cell, sometimes spray foam. Rarely do we use a batt insulation. But even with a batt insulation, we can effectively insulate that corner and stop or minimize the thermal bridging. It's still a concern right here, but you see there's far less mass, there's far less lumber to actually conduct the warmth or the cold. Interior partitions are another issue. This is a neat detail. I'm guilty of this one too. And at the top, we used to build U-channels. That's what the boss used to call them. Build the channels, build the U-channels. We'd take 3 studs and make a channel, and we'd invert it. And you had this huge pocket right in there that was impossible to insulate effectively. We attempted to do it just like we did with these corners. We'd stuff fiberglass in there. I'm sure it serves no purpose. Instead of building these U-channels, because frankly, what do you need all this lumber for? What's the real concern? What's at issue? Keep in mind, this is not a bearing wall that we're talking about necessarily. This is just an intersecting partition wall. So why do you need all that lumber? This is what we used to do. See, it's impossible to insulate effectively. This is what we now do. We take a 2x6 and we run it depending on the wall height. If it's an 8-foot wall, continuously. If it's over 8 feet, we typically will put horizontal blocks in periodically, or we'll just eliminate this altogether on a really tall wall and put horizontal blocks, like a ladder frame assembly. That detail is shown, it's not very clear, but that detail is shown right here. I'm not a real fan of that, primarily because our drywallers don't like it, and I don't like the subs complaining about the details when we build. So we do try to use the 2x6 backers whenever we can. It's actually less labor, it's less wood, it's less everything. Still another option is to use drywall clips. That's shown right here. Instead of a 2x6 backer, now you only have a 2x4 backer. You build it just as you would for a partition. It would be the backing for the partition. You inset it, flush with the top plate. It's a stud, but on the flat rather than on edge. And there are pre-manufactured drywall clips that you go around and you screw in, and they receive the drywall. They come in different thicknesses, different widths for different thickness drywall. The drywall literally just slips into place. This is kind of a variation of steel stud framing. When you do steel stud framing, often when you've got a bi-wall or an intersecting wall, you'll leave the last stud loose when you're framing. You leave it loose completely. Put it in place, but leave it loose. Leave it float in the track. When the rockers come in, they run their rock all the way through that. And then they push the studs tight against the wall. It's very efficient. There's far less cutting to do. This is, to a certain degree, a variation of that. You don't need a lot of support to pick up the edges of the drywall. So this is really very effective. And again, it minimizes the amount of lumber that you're using. hence the amount of thermal bridging that you may have. This is yet another option. This is a staggered wall assembly. You guys anybody ever seen this? This is essentially a 2x6 wall assembly, but with staggered studs. You can see the only thermal bridging you would have would be on the top plate and bottom plate. That's it. The studs never go all the way through. They never come in contact with the interior. It's a bit of a challenge to insulate if you're going to use batt insulation, but I've seen some people weave it through there. I wouldn't recommend it, but it lends itself beautifully to dense pack cellulose or to spray foam application. It's looks a little odd. It takes a little bit of getting used to lay it out. You got to really know where your doors and windows are and plan for everything, but it's very effective. And actually it uses less lumber, believe it or not. It uses far less lumber than a 2x6 wall assembly because you only have 2x4 studs, and they're still 16 inches on center. It doesn't look like it, but they are. But if you look at it, if you just look at each set on the interior or each set on the exterior, they're just 16 inches on center. So it uses less lumber, minimizes thermal bridging, lots of good stuff.